Welcome to the 21st lecture of Polymer Science and Technology. In this lecture, we will see the concept of average kinetic chain length, which is represented by the nu bar. Average number of this is actually the average number of the monomer per unit chain initiated. Okay, so there is a difference between number of repeating unit and average kinetic chain length. Average kinetic chain length is number of monomer unit per chain initiated. So there may be difference in the number of chain initially initiated and the number of chain finally remaining in the polymer. Why? Because in termination step, chain may either couple or disproportionate. Okay, if two chains are going to couple, then number of chains initiated will be half of the final chains in the polymer. Okay, so the number of chains in the final polymer will depend upon the mode of termination, whether mode of termination is by coupling or by disproportionation. And here it is important to understand that in any polymerization reaction, the mode of termination is not exclusively by any of this technique. Neither 100% chains are going to terminate by disproportionation reaction nor by coupling reaction. Rather, it is a combination of these two methods. Okay, so it is very difficult to tell how much chains will terminate by disproportionation and how much number of chains will be terminated by coupling. So in nutshell, what we can say that the number of chain initiated may be different than the number of chains finally present in the polymer. Okay, so what is kinetic chain length and average kinetic chain length? Average kinetic chain length is the number of monomer per unit chain initiated. For example, if let's say we have started with the 1000 molecules of monomer, okay, and at that time 100 chains were initiated, means there were 100 free radicals formed during initiator decomposition that generated 100 free radicals, and initially 100 chains were initiated. And how many molecules were there? 1000 molecules of the monomer. So 1000 molecules of monomer divided by 100 chain initiated, that means on average there will be 10 molecules of monomer per chain initiated. So this is the concept of average kinetic chain length. Now this average kinetic chain length, nu bar, can be represented as Rp, rate of propagation reaction, divided by Ri, rate of initiation reaction. And according to steady state assumption, Ri is equal to Rt, then this equation will become Rp over Rt. Correct? Now the degree of polymerization or number average or the Xn bar, degree of polymerization, that is also number average degree of polymerization represented as Xn bar, will have two values. One, Xn bar is equal to nu bar when the mode of termination is disproportionation, and Xn bar is equal to twice of the nu bar when coupling chain is terminated by coupling. So this I have already explained you. So Xn bar is equal to nu bar when disproportionation, because chains are not going to be coupled in this case, and in case of coupling the Xn bar is equal to 2 times nu bar. So new bar is Rp over Rt. Let's put the value of Rp. This is a Kp concentration M times concentration M dot over 2 Kt concentration M dot square. So square and M dot will cancel out and it will be Kp concentration M over 2 Kt concentration M dot. So from this equation we can from the earlier equation we know that the value of the concentration of M dot is equal to under root f kdi over kt. So we'll put this value in this equation of nu bar, and nu bar will be kp m over 2 kt under root f kdi over kt. So finally we'll get the equation for nu bar as this. Okay, and what we can conclude from this equation, that the nu bar average kinetic chain length is directly proportional to concentration of the monomer, and it is inversely proportional to under root times concentration of initiator. Increase in initiator concentration will increase the rate of polymerization. That is, rate of polymerization is proportional to under root times of concentration I, but it will decrease the molecular weight of the chain because average kinetic chain length is inversely proportional to under root times of initiator I. So what is the message to be remembered? That any attempt to increase rate of polymerization by increasing the concentration of the initiator will result into decrease into molecular weight, because average kinetic chain length is going to be decreased by the increase of concentration of initiator. So this is very important to remember as a process engineer, that you should not attempt to increase the rate of polymerization by increasing the rate of by increasing the concentration of initiator. Otherwise what will happen, the targeted molecular weight will not be achieved and we will get less molecular weight, means less mechanical properties, less thermal properties, reduction in strength, etc. So this is to be remembered from this equation. Okay, now the final topic of this unit is the gel effect. I think gel effect I have already covered in first unit, but again I can tell you during the polymerization, especially in bulk polymerization, what will happen, because the viscosity of the monomer initially taken is very low, but once they will start reacting, polymerization reaction is an exothermic reaction, so heat will be generated, as well as at that time the molecular weight will also increase. Once the molecular weight will increase, then it will lead to increase in the viscosity of the reacting mass. So when viscosity of the reacting mass will increase, it will result into the poor mobility of the reacting species, especially polymer chain. The chain mobility will decrease, and because of the reduction in the chain mobility, the rate of termination reaction will reduce, because termination reaction depends upon the number of the collision between the chains. So if chain mobility has been reduced by the increased viscosity of the system, so rate of termination will also reduce. So once rate of termination is also reduced, then this steady state will shift, and result of this will be increase in the radical concentration. Any radical concentration of the secondary radicals mean m dot concentration will increase. once m dot concentration will increase, it will lead to increase in Ri, initiation rate of initiation, because more number of free radicals are present. So once more number of free radicals are present, then what will happen? Rate of polymerization will increase, Rp, and once Rp will increase, that's mean more monomers will be getting attached to growing polymer chain, and polymerization reaction is exothermic reaction, so lot of heat will be generated, because the amount of heat generated in exothermic reaction will depend upon the rate of reaction. So rate of reaction is increasing, so heat generated will also increase, and once heat will increase, it will further increase the rate of initiation, because the thermal decomposition of initiator will increase the free radicals in the system. So here there is a circular loop. Ri will increase Ri, and Ri will increase Rp. So a circular loop is there, and it will cause auto acceleration, and as a result viscosity of the reacting mass will increase, and this increase in viscosity again will take this loop, and this is an condition of auto acceleration, means rate of polymerization reaction will accelerate on its own, and this may leads to uncontrolled polymerization reaction, and sometime some disaster may also take place because of uncontrolled polymerization reaction, which is exothermic. Lot of heat will be generated. In nutshell, some explosion kind of condition may take place if it attains the flash point of the monomer. There are chances of explosion. So we have to control this condition. And how we can control the gel effect? We can control the gel effect by controlling the heat of exotherm, by employing proper cooling system inside the reactor, okay, proper cooling jackets. So, or we can use the solvent to reduce the viscosity buildup and ease out the heat generated during the polymerization reaction. So this going to introduce another kind of polymerization system, which is known as solution polymerization system, that you have already learned in the previous unit. So this is the condition of auto acceleration, and this is the end of unit 2, and we'll continue next lecture in unit 3. So thank you for your patient hearing.